Have you ever looked at a photo and just knew there was more to it? Like details hiding in the shadows or totally washed out by the glare? Well, today we're diving into the pretty amazing world of digital image enhancement. This is where technology basically gives us superpowers to see the unseen.
So take a look at this picture. At first glance, it seems fine, maybe a little dark, a little plain. But what if I told you that locked away inside its pixels is a ton of information, just waiting for us to find it?
And that's really the million-dollar question, isn't it? How do we get that information out? Well, the answer is in this powerful set of techniques that act kind of like a digital key, letting us unlock all those hidden details. This is what image enhancement is all about.
So, what is it really? At its core, image enhancement is the art of making a picture better for a specific reason. And here's the key thing. It's not about faking it or adding stuff that isn't there. Nope. It's about taking the information that already exists and just making it clearer, easier for our eyes or even a computer to understand.
Okay, so let's get into a picture's hidden secrets. The real problem we're solving here is that every digital image is just a grid of data. But things like bad lighting or digital noise can mean that data isn't always presented very clearly. To fix this, we basically have two main toolkits at our disposal. Think of them as two totally different ways of thinking about how to improve an image.
And here they are. First up, you've got the sculptor's approach, which we call the spatial domain. This is super hands-on. You're working directly on the pixels themselves, kind of like a sculptor shaping a piece of clay. It's fast, it's intuitive. Then you've got the composer's approach, or the transform domain. This one's a bit more abstract. Instead of pixels, you're working on the image's frequencies, its basic patterns of light and dark, almost like a DJ remixing the notes of a song. It is incredibly powerful for making big changes to the whole picture.
So let's crack open that first toolkit and get our hands dirty with the spatial domain, where we're going to be changing pixel values directly to get some immediate results.
You know, the most basic operations are just simple math. It's kind of wild. To make an image brighter, you just add a number to every single pixel. Want to boost the contrast? You multiply. And to create that cool negative effect, you just subtract each pixel's value from the maximum. These are really simple changes, but wow, they can have a huge impact on what we're able to see.
Now, a slightly more advanced tool is something called histogram equalization. Just imagine all the shades in your picture are kind of bunched up together in one little gray area. What this technique does is automatically stretch them out across the entire spectrum, from pure black to pure white. The result? A massive boost in contrast that can reveal details you had no idea were even there. This is a huge deal in medical imaging, by the way.
And then there's filtering. The way this works is you take a tiny little grid, it's called a mask or a kernel, and you slide it all over the image, pixel by pixel. Depending on the numbers you put in that little grid, you can do some amazing things. You can average out the pixels to smooth away noise, that's a low-pass filter, or you can crank up the differences between pixels to make edges super sharp, that's a high-pass filter. All right, time to put down the sculptor's tools and pick up our second toolkit, the transform domain. This way of doing things is way less direct, but believe me, it is incredibly powerful. We're not thinking about pixels anymore, we're thinking about the image's fundamental patterns.
The magic wand here is a mathematical tool called the Fourier transform. The best way to think about it is like a prism. You know how a prism takes white light and splits it into a rainbow? Well, the Fourier transform does the same thing for an image. It breaks the picture down into all its different frequencies. Low frequencies are the slow, smooth parts, like a clear blue sky. High frequencies are the sharp, sudden changes, like the crisp edge of a building.
And once you've separated all those frequencies, you can apply some seriously powerful filters. A perfect example is homomorphic filtering. This technique is just brilliant because it does two things at once. It fixes uneven lighting across the whole image, and it boosts the contrast. It is an absolute game changer for pictures taken in really tricky lighting.
Okay, so all this theory sounds great, right? But where does it actually make a difference in the real world? Let's look at a pretty high-stakes case study from the world of medicine.
So here's the challenge, and it's a huge one. Doctors need to spot really subtle signs of tuberculosis on chest x-rays, but these images are often low contrast, which makes finding those early signs super difficult. So the question is, can this technology help them see more clearly?
And the answer was a huge, resounding yes. What researchers did was apply a multi-step process. And check this out. They used tools from both of our toolkits. They started with histogram equalization from the spatial toolkit, Then they applied homomorphic filtering from the Transform toolkit, and they finished it off with unsharp masking, another spatial tool. This hybrid approach, well, that was the secret sauce.
And the impact was undeniable. This combined process led to a 35% improvement in the image contrast ratio. Now, that's not just a number on a page. That is a massive leap in visual clarity for the doctors who need to make life or death decisions.
And here it is, the human impact. This is what it's all about. This isn't just making prettier pictures, it's about getting better outcomes. Because of these enhancements, doctors could literally see things they had previously missed. This technology directly helps them make faster, more accurate diagnoses.
I mean, that's already so powerful. But what's next? Well, no surprise here. The future of image enhancement is being written by artificial intelligence.
To really get where we're going, it helps to quickly look back at where we've been. Our two toolkits each have their strengths, right? The spatial domain is simple, it's fast, and it's great for local changes. The transform domain is more complex, yeah? But it gives you this amazing global control. And as we just saw, the best results usually come from mixing them together.
And that's exactly what AI is learning to do. It's wild. Some brand new research from 2025 shows off a new model that's a hybrid. It combines two different types of AI. It basically learns to be both the sculptor and the composer, all at once, automatically. And it just won a huge competition for enhancing pictures taken in almost complete darkness.
So, to pull this all together, what are the big takeaways here? First, image enhancement is all about improving the quality of what we can see. Second, we've got two main ways to do it: the direct, hands-on spatial domain and the more abstract, frequency-based transform domain. Third, mixing these methods together is usually the most powerful way to go. And finally, AI is completely revolutionizing the whole field.
And that kind of leaves us with one final thought to chew on. We are building technology that can see with superhuman clarity, revealing things that are totally hidden from our own eyes, and everything from medical scans to pictures from space. So the question is, as this technology keeps getting better and better and starts to see more clearly, what will it ultimately see in us?